Let's continue from the last video. So in the last video, we have discussed about the limiter function of two variable. We had defined that. We had defined a limiter function of two variable, right? Limiter f of xy, limit of f of xy as xy tends to x naught y naught equal to L means for every number epsilon greater than 0, there exists a corresponding number delta greater than 0 such that for every xy in the domain of f, 0 less than mod x minus xy minus x naught y naught less than delta implies mod f of xy minus L less than epsilon, which implies 0 less than distance means root square root of this one is less than mod f of xy minus L is less than epsilon, right? This writing is same as in the case of the one variable, only approaches is slightly different from this one variable, right? Okay, so here the definition is saying that when xy approaches to x naught y naught, right? Through the distance that is 0 less than square root of x minus x naught whole square plus y minus y naught whole square is less than delta, which implies mod f of xy minus L less than epsilon, right? So which implies this is a function, this is a point x naught y naught, right? So xy approaches to x naught y naught in this manner. That means this is the disk. Square root of this means this is a disk with a radius delta, right? So when the points in the disk approaches to this x naught y naught through any direction, right? Then there will be a, suppose this is a L band, right? Then this function f of x, this is L, then this is L minus epsilon, L minus epsilon, and this is L plus epsilon, right? So and this is L plus epsilon and this is L minus epsilon band, and this is equal to, right? So this f of x approaches to L and this f of x lies inside this band. When xy approaches to x naught y naught through any direction, then this f of x lies in the same in this L band, L minus epsilon to L plus epsilon band, right? Lies inside this band. This is the meaning of this definition, right? So and also note that in the case of the one variable, we have the limit of f of x, limit of f of x, this is note or remark, limit of f of x approaches to L, limit of f of x approaches to L as x approaches to A from either left or right must be L. The similar situation occurs for a function of two variables with the difference that the point xy can approach AB in in infinite directions. XY approaches to AB to infinite directions, right? So, if you can, hence, if you can find two directions, if you can find two directions toward AB with two different limits, with two different limits, with two different limits, then function has no limit, has no limit as xy approaches to AB, right? So this xy can approaches to AB as in the case of here, right? So xy to this is x naught, y naught. So this any point, the xy can be any point on this disk, and through any direction this can approach this x naught, y naught through any direction. So if you can find two directions towards AB or x naught, y naught, or x naught, y naught with two different limits. So if this definition, if a function of two variable have a limit L, means through any direction this xy approaches to x naught, y naught, this f of xy approaches to L, right? So I am taking this direction, right? Then I am approaching this xy through this direction to x naught, y naught. Then what will be the value of f of xy? F of xy must be equal to L. I am choosing another direction also. This is direction. I am choosing the xy here, right? This xy approaches to this x naught, y naught through this direction. Then f of xy must have the value L. And again I'm choosing another direction through this direction, right? I can choose any direction. It is not straight, it cannot be straight line. It can be straight line or any direction, any curve, through any curve or through any straight line. I can approach to x naught, y naught. So if I am choosing this curve to approach from x naught, xy to x naught, y naught, then f of xy must have the value L, right? So hence if you can find out the two directions towards AB with the two different limits, then the function has no limit as xy approaches to AB, right? So there are some theorems in this, right? Some theorems results in this based on that. So I'm going to define that result. So you had to check it for a function of function of one variable. First result is that limit xy approaches to x naught, y naught, x equal to x naught. Second one, limit xy approaches to x naught, y naught, y equal to y naught. And the third one is limit xy approaches to x naught, y naught, k, a constant k equal to k. Again, one more theorem. Check it whether you can prove it or not. After that we can discuss, okay? If you get the answer, then please put it in the WhatsApp, right? So next we are going to explain the theorem 1. It is simple actually. The properties of a function of two variable, right? So for that, suppose that limit xy tends to x naught, y naught, f of xy equal to L, and limit xy approaches to x0, y0, g of xy equal to m. Then the results are the sum rule. What will be the sum rule? Limit of f of xy plus g of xy equal to L plus M as xy tends to x0, y0. And the difference rule, limit f of xy minus g of xy equal to L minus M. Product rule, limit f of xy into g of xy is equal to L into M, right? So on the fourth one is constant multiple, limit k into f of xy is equal to k into L. And the fifth one, quotient rule, limit f of xy divided by g of xy equal to L by M. What will be the case? If provided that M not equal to 0. And also one more result, limit f of xy whole raised to m by n equal to L raised to m by n, provided L raised to m by n is a real number. And this result happens as xy approaches to x0, y0. As xy approaches to x0, y0. L and M are real numbers. Right? I think you can prove this very easily. You please do it. Okay? So, in the next class, we can discuss some examples, right? The examples and the definition for continuity and so on. Okay? Thank you.